video that we're currently watching, but also, you know, follow along here, but especially having it on your side as well.
Tree AI. This is going to be a beginner's tutorial. So straight away, I'll just show you how to make a project. I guess we'll keep this really simple. Open your Epic Games launcher. Click launch of your engine, whichever engine you've got installed. So that's up in the top right. I'm in 4.27 today. Click games, new.
Which is awesome because most of this stuff is universal.
Third person.
And I did see, like, there was one thing in the comment that we might have to come across, but that's not too bad. Which is unfortunate that there's, in this type of video style, not that many of videos like this. But still is really good, though. That it's actually applicable still.
Starter content enabled, and then all the other settings there are fine.
Okay, so enabled. Okay. That's what I want to know.
And then I'm going to call this Tutorials 2023, and I'm going to turn this into a tutorial series, I think, where we cover...
Wait, did it go in third person?
A lot of the basic stuff in Unreal Engine.
I think it went in third person.
Explain it properly, because in a lot of my previous videos, I've sort of just blitzed through things, and I never really explained a whole lot of what was going on, so that's what we're going to do.
I think that said third person. Yeah, third person. Okay, just making sure. Third person with starter content. I think, right? Actually, I don't see no any content. Or you said without starter content. Oh, no, there it is. It's just kind of, what you could actually do, because here, actually, let's just cut this. This would be trees test. Great. Actually, what is he going to make?
A little bit in this series. We're going to slow it right down. So in my content browser, I'm going to right click and create a new folder and just call this tutorials, because this is where I'm going to put all the tutorial content. Now we're going to...
Okay, he's going to put that there. Okay. Yeah. Assets.
I'm going to be creating a simple AI from scratch today. AI meaning artificial intelligence.
Or is he doing blueprints?
Which can move around randomly, and we're going to use behavior trees to do that, because behavior trees are a much more powerful way to do AI than just inside of a blueprint event graph. And that'll become obvious why as we go on. So to create a new character, we're going to go new blueprint class and type character, and just call this BP underscore
blueprint class type character.
My simple character. I like.
Okay. BP underscore my simple. Now, so this stuff is going to be looking a little bit different, but we could actually go to this version of what Unreal 4 looks like. I actually prefer Unreal 5. So, you know, sorry to everybody who actually prefers that stuff. This is actually something that turned me away from Unreal when I used it back in the day, was just the UI. Now, even though it's like mostly the same, just a little few different slight variations, it just it's like eye candy more. And it's way easier to understand.
I like to put my in front of things to differentiate it between something else that might be in the editor that I didn't make, so I know everything with my in front is mine. Now, straight away we can drag him in.
I'll follow his format.
You can't see anything there because he doesn't actually have a body, so let's just give him a body. This is what he looks like right now. So if we go add mesh component and go static mesh and just call that SM, and then just add a cube, our dude can be a
cube. Background cube. There's a few cubes. Editor cube, particle cube, cube. Is this it? Because I tried to do this in my own thing and did this material, which I don't like. Which is, I'm just gonna type in cube. Because there was actually cube colors like this. I'll do that.
A cube today. Okay.
Actually, what is there? Actually, I'll do blue. Yeah. I want to blue. Okay.
That's rad. Okay, so that's our AI. He's there.
That's a big square. Oh, I see. That's right. The capsule component. Yeah. And oh no, not delete. That's right. And so the capsule. But you gotta do what you gotta, you know, make do. Boom. compile. And that's good. And then, oh wait, compile, one save, boom, compile save.
There, okay, that's his body. He exists.
Right.
He's in a world, right? But at the
Our
moment,
world.
he's just a body, and
Yes.
he doesn't have a. The way I like to think of AI is like, AI is sort of the brain that you give to a character. This is just another
Okay.
character here. Now, if I hit play and jump in, this character has been possessed by my controller, my player controller. But this dude over here, this hasn't been possessed by anything. He's got no brain. He can't do shit.
I see. Okay, I see what you mean.
And likewise, if I just hit simulate like this, we've got two characters, the one that we just created, and this other character that started in the scene. And they're both bodies, but neither of them have got any brains, and they don't actually know how to do anything.
Right.
So that's the first sort of concept,
Also,
I guess, is this idea.
Wait, simulate? Now, wait, how did you do that? Which button did you press? Process pause, or did you just... I think it's talking about game
It's
mode.
like you can have a character.
Actually, I don't know. Either way,
that
that's
exists in
okay.
your game, but he's just a body.
We saw what
unless
he's
you
talking
give him
about.
a brain. So the next thing that we need to do if we're going to be creating what we call AI, which is
Yeah.
artificial intelligence or shit moving around like by itself as if it
Yeah.
had its own free will and like whatever. We need to go into our content browser, new blueprint class, and we need to make a brain for the AI. So if you go to all classes down here and then type in AI controller, you type in AI controller, you select AI controller, and I'm just going to call it AIC underscore well, we'll call it simple brain because it's a simple brain for an AI. So down in the content browser, we have the body and we have the brain. Now we need to tell the body to use the brain. So if we go into the simple character.
Hold up. Oh, yo, that's so cool. Okay, so we're getting into some like stuff of the other classes. That's awesome. So go into this character, also perspective. Okay.
Click on the top there, my simple character, and then over on the right, AI controller class. It has been given a brain.
AI controller. He's in the pawn. Do we have? I'll just type in. Yeah, it's okay. So it's still underscore pawn. Okay.
Controller, but that's just the default one. We're going to tell it to use our brain.
AIC simple brain. Save.
Auto possess AI placed in world.
Okay, let's actually go to pawn. Disabled, placed in world, or spawned.
Or spawned. I always like that to be or spawned.
Okay.
So whenever you spawn one of these in the game,
Yeah.
Sometimes your AI doesn't do anything because it doesn't actually have an AI controller. So I always like to have this set there. Okay, so now he has a brain. Now we have a body.
Yes.
We have a brain. Now we need, what would you call it? Like neural networks and like subroutines and things that it can do. Like if you think about a person and the behaviors that a person engages in, one way to conceptualize their behavior is it's sort of like a script that's running inside their brain which is controlling their body. That's one way to think about it. Or you can think of it as like a script which is executing itself through a person's soul which is a player controller which is then animating their body. That's another way to think about it.
I get what it means.
It's the same with AI. The AI has a brain now. It has a body which can move given inputs from the brain, but the brain doesn't have any information to actually execute. You need to feed information into the brain and invent decision making and routines and movements and actions to tell the brain how to use the body. So that's the next thing that we need to do. And the way that we do that, you can do it in the event graph, but anything in this event graph is not reusable across different characters. It'll be restricted to this event graph or anything that we create a child from this event graph. So if you want to be able to use different behaviors for different brains in different bodies, you can abstract all of that out into what's called a behavior tree and in behavior tree tasks. So that's what we're going to do now. This is really, really simple. There's so many complicated tutorials on this shit, and it's like everybody sort of misses the point. Behavior trees are literally just it's a mechanism for decision making, and they don't have to be complicated at all. So if you got artificial intelligence and then type in behavior tree and just call this BT, and now let's give it a specific name, knowing that this is not tied to a character. So I'm not going to call this my simple character, BT underscore my simple character,
So what would you call
because
it?
the simple character is a body, and I'm not going to call it BT
brain?
underscore simple brain, because it's not a brain. What this is this is a set of instructions and a particular pattern of behavior, which is then fed through a brain and then executed in a character. So if you think about it in terms of a behavior, what kind of behavior is this? Today we're going to call it random roaming. Okay. Hopefully I'm not going too fast. If this is the first time you've watched something like this, a lot of what I'm saying will be too quick, and you won't be able to digest it, which is okay. So what I recommend to do if you're watching these videos and you're new to Unreal Engine and you're new to game development and a lot of the concepts that I'm talking about here, is to watch these videos from start to finish first without trying to build anything that I've been making. Maybe even watch them twice, and then once you feel like you understand everything that I'm saying, then what you do is you go back to the start, you watch it, you see what I'm doing, you pause it, you recreate what I'm doing, you start it again, pause it, create what I'm doing, and skip back and forwards as you need. That's how I recommend that you do it if you're a beginner to this stuff. If you're advanced,
I would just do it over and over. That's the way I do it. I do it, follow it, and if I need to go back to the tutorial, I'll just do it again. Or, well, yeah, of course, do it again, but that time, it's always more clear. And then after, basically the second time or third time, depending on whatever it is, then I'm kind of like set.
And I've got plenty more advanced tutorials on my channel where I just blitz through shit like a fucking psychopath. A psychopath on 24 Red Bulls and some LSD. But today we're gonna just be just chilling and going slow and vibing. All right, this is sort of hangout, in-depth learning time. So we're gonna have a random roaming behavior. Now, if we open that up, there's not a whole lot in here. Because
it's pretty simple.
Well, it's not meant to be, because it's like basically a blank piece of information. We're gonna have a selector node, which selects stuff. We're gonna have a wait node, which waits. Really simple stuff so far. So basically, if I ran this now, I mean, this is already a behavior tree technically, like literally. So why don't we just run that? We can literally run this now, and I can show you it running. So to get this guy to run a behavior tree, we could, inside of the simple character, go begin play, run behavior tree, blah, blah, blah. But then you'd have to add this for every single character. Like if you wanted to have a separate character, you know, which could be BP, my second simple character, and say he was like a freaking triangle or something, like if he was completely different, you'd have to tell this to run a behavior tree as well. And then it's like you're copying code from character to character, and you don't need to do that. Whenever you find yourself copying lots of code, there's probably a better way to do what you're doing.
Good to know. That's actually huge to know.
So you don't want to be using the same code in different places. You want to be using or copying the same code to different places. I mean, you want to be using code in different places, but all drawing from the one place. And so the way that I like to do that, I mean, there's a million ways that you can do this, but the way that I do it is I create a blueprint class. I create an actor component and call this AC underscore run behavior or something like that. An actor component is literally what it says it is. It's a component which can be added to an actor.
I'm not spelling that right.
So,
hold up. Oh, you didn't open it. Okay. So it's in here.
If I go into my BP simple character, and
add
AC, what did I call it? Simple or run behavior or something. AC run
Okay.
behavior and then just add that in.
Okay.
We can get this to do all the scripting just by itself. So inside of
Just
AC
being in
run
there?
behavior,
Oh wait, hold up. Now he's in it. Okay, so now he's in AC run behavior because that's the actor component. First time ever getting into these blueprints. So this is actually really sick. And actually surprisingly simple in comparison to what we've been getting into.
on begin play, what we're going to do is we're going to get the owner of this component, which is my simple character.
Get owner.
We're going to get AI controller. Okay.
Okay.
And then we're going to say run behavior tree.
And behavior tree.
We can promote this to a variable by dragging off of here and just call this BT, I guess. And we'll make that...
No. Behavior, promote the variable. BT asset? Did you just keep it? Oh no, it's BT.
Tick the I on that, so that's a public variable and that can be edited. And then basically
Interesting.
any actor that has this component will just run a behavior tree straight away off the bat. So if I put in as the default for the BT, our random roaming behavior tree, this is done. We can close that component, and now this guy here at begin.
Oh, I see. Actor components. Ah, I see. Because it goes. Ah, okay. Right. That's pretty simple.
Player is going to run that behavior tree. Now the other guy, we can get him to run it as well, and we don't need to copy code. All we need to do is just add in this.
Can we just make a child off the first one? Or AC run behavior? Because it would be the same one, but it would be different like models and stuff, which you could change and everything.
Yes. And they're both going to run the same behavior tree. I prefer to do it this way rather than copying code in case you want to add more complex logic to which behavior tree they should be running.
I see.
So now
you could still do that with.
If I
Actually,
let's
no, you
delete our
couldn't.
second guy, but if
Actually,
I
could
hit
you?
play,
Could you do that with the child component? Is edit the make it more advanced? Okay.
now it looks exactly the same.
Now hold up. This isn't a whatchamacallit. This is not a child component, so you know what I'm gonna do? Oh, actually make it red. I'll save. There we go. Nice.
Same as before, but if I open up the behavior tree,
Oh, wait, is it playing? So, does it actually work like this or no? Or did I just do this? I can do that too.
da, 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 da,
Okay, so it's waiting.
you can see
Wait 5 seconds.
there is an option up here somewhere. You can select the AI from the drop down. AIC simple brain C _
And he's selecting, behavior tree. No. AI, miss. AI. Is the other one not selected? No, wait. Is it because it's not playing? Oh no, it's because it's not playing. So yeah, there is. Okay, so there's 0. And then 1. Yeah, so yeah, I saw it swap over because it was slightly different.
_0.
Or like it paused.
This is just saying that it's running. This behavior tree is running on this brain. Okay? And this brain is inside of this guy here. If you want to think about it
both
like
of them.
that. So he's successfully running a behavior tree already.
So
Cool,
okay.
right? Like really, really, really simple. So now if you wanted to get him
How
to
do we
do
step it
something
up a
more
little bit?
complicated, what we do is we use these things up here, which is called a task.
What task?
So maybe what we can do,
Okay.
we can use a sequence node, and the reason that I'm adding this over to the left
Sequence.
is because this is how the decision making works in behavior trees.
So
So this is a
selector.
new concept that I'm about to teach right now. Execution starts at the root, and you can think of
Yes.
it like water, which chooses which way it wants to flow down. And the whole system of behavior trees is designed to choose which behavior should be running given a set of circumstances or input. It's like, if you think of the way that your brain runs its behavior tree, it's like if you're about to cross a road and you use your perception and see that there's a car coming and you don't want to die, you will block off the behavior that says cross the road, and you'll probably just wait until the car's done crossing the road. And
I see. So you're talking about like the priority
car's
stuff.
done passing, and then you'll cross the road.
How do you set the priority?
It's the same thing with behavior trees. You can have different gates on these. So, for example, if I had a blackboard on here, this checks a condition to see, oh, well, is there a car coming?
Wait, what? At a gate. Blackboard? It's called a decorator.
If there is, then this whole branch is going to fail. We're not going to cross the road. Instead, we're going to do this branch over here. And the way that this works, the way that the behavior tree selects which node to run, is it always checks from left to right. So if we go down to this selector node,
goes left.
The first one that it'll try to select is on the left here. And then if this fails, it'll go to the next one, check that, next one, check that, next one, and it'll keep going until it succeeds.
So that's why the
So
stuff
what you
is
always
like that.
want is a wait over here on the right, because if everything else fails, then you just end up waiting for a second or 5 seconds or whatever.
Okay.
Okay? It's simple enough. So let's
How do you
let's
do
see
that?
if we can build our first behavior, which could literally just be
There we go.
Oops,
Just
I
click on
clicked
it and
new
delete.
task, which I didn't really mean to, but hey, let's just roll with that. Straight away, what I like to do.
I was looking at that for a second. Hold up.
Which I didn't really behavior, which could literally just be
So click this and click new task.
which I didn't really mean to, but hey, let's just roll with that. Straight away, what I like.
Do I do it? I guess so. Okay. Whatever.
To do is go Control Shift S to
Wait, how does it? Okay, yeah. You've got the default name. Control save.
save it because it had a little asterisk, and then I go Control B and it browses to where that task was created. So I'm going to call this BTT, hitting F2 to rename it. BTT
underscore
get random location near actor. This is a task that a brain can run. Okay, so you want to keep that in mind when you're naming things.
Oh,
so let's just
okay. So
before
we're just...
I add code to anything.
Wait, we made a task from. We made a task from the actual behavior tree. Oh, so it creates a new. It says it right there. It creates a new task node blueprint from base class, and that's where we're gonna put this stuff. And that's gonna be like a node under here, kind of like an add custom node from like the blueprints.
Let's look at how this might look. So this node up here was the select node, which selects the first
and this is
node
sequence,
and
which
starting
is different.
from the left and then moving progressively to the right. A sequence node runs all of its nodes in sequence, and you can hover over these if you want to read them. So if we think about what we want to happen, the first thing that we want to do is if we're going to be building a random roaming behavior, which is what we're going to be doing, by the way. Spoiler alert, I don't know if I mentioned...
Wait. There it is, BTT. So, okay, so... Oh, no. So there's this.
That. The first thing that we'll do is we'll get a random location near actor, and that actor's going to be ourself, because we're just going to be roaming around our immediate location. Like, sort of simple stuff.
Right.
We'll do more complicated ones in future videos, perhaps. Get a random location, move to location, which already comes inside of the editor. That's a default one.
The move
and then maybe what we'll do is we'll wait there for 2 seconds plus or minus 1 second. Okay.
2 seconds, and plus or minus 1. Okay.
And then once that's finished, this whole thing has then succeeded. This whole sequence has then succeeded.
And then goes to wait.
Which means this selector node has then succeeded, which means it's done, the root's done, and then the root will fire again, and it'll do the same thing again.
Oh.
If this were to fail, the select node would
fail.
then
Okay.
cut that branch, and it would go to the next thing on the right, which
So
is
you
the
have
wait.
to make it fail.
And after it waits for 1 second, that task succeeds. This succeeds. The root succeeds, and then the root fires again and tries again. So it'll try from the left and then go again to the right.
Okay. And if it succeeds the next time,
So that's how behavior trees work. Now, this is not going to roam at the moment because it doesn't
That's actually really simple.
actually have any logic inside of this task,
We're talking about like AI right here, you know what I mean? Like that's actually kind of pretty cool and crazy.
which is getting a random location near actor. So if we double click that, we can open that up.
Oh.
Now, first thing, I type in recx AI, event receive execute AI.
What? Dude's giving me like crazy nodes here. Receive execute AI. My goodness. That's a mouthful.
Which just means
This behavior stuff is amazing. This is really cool.
this task has been fired / activated / whatever.
Wait, receive execute AI. That's not... Okay, so... That's not very simple on that. But that's like... If you were to click override... Oh wait, does it do it here? Receive execute? Execute AI? Already did that, so it wouldn't be here, right? I don't know. But, this is like a base thing. So, no matter what you name it, you create a new task, create multiple tasks. You would want to, I guess, like always want to make this? Or most of the time?
The controlled pawn is our character, which is possessed by the AI controller.
So do we do self?
That's this. And then the owner controller is the AI controller, simple brain. Okay? If we want to get a random location near the controlled pawn, we get a reference to the controlled pawn, and we could say get location, get actor location, and then we could
get actor location.
Get random point, get random reachable point in radius.
Okay.
See, there's already a node that does it.
That's actually really nice.
The origin will be where we are, and the radius can be a public variable, so we'll drag that off and promote, and just call that radius, literally. Nice and simple,
Awesome.
and then make that public by clicking the I so we can edit it.
Boom.
Now,
File save.
once we've got that, we can finish execute. So the thing about these tasks
Okay.
is that you need to actually mark them as a success, otherwise you need to mark them as a success inside of the task itself, otherwise the behavior tree has
Finish.
no way to tell if
Success.
this actually succeeded or if it failed. Because sometimes, for example, if you
Interesting.
can't find a location, you might want this to
Right.
fail, because you don't want to try and then continue in the sequence to move to a location that it couldn't find, right? So if this fails,
Yes.
the whole sequence will fail, and then the selector will default to the next task on the right. So that's something to keep in mind when you're doing these tasks, is you need to remember to finish execute after you've done your script, and then have different conditions for success versus fail, because then that can control how the behavior tree works its magic.
It doesn't have that marked as success though.
So in our case, as soon as you get the location, I mean, we're just going to assume that it's always going to succeed, because it probably will. I think it will. So then
Range?
what you do is you just go finish
Okay.
execute success. Now, the value's here, but we can't do anything with it from inside of this. It's like, okay, well, we've got the random location, but like, how do you get that from here inside of this task into this move to node to tell the brain, or the software on the brain, to move to that actual location? And the way that you do that is with a thing called a blackboard. So let me create a blackboard, and then I'll explain what that does.
All right, so go back to here.
So if you right click in your content browser and create a blackboard,
Artificial. Okay, so we're going to the artificial intelligence blackboard. I love these icons and everything and the colors and make them so different.
And then call this BB underscore.
BB.
This could be called basic blackboard. BB for blackboard, basic blackboard.
Basic blackboard, interesting.
And what this is...
Oh, okay.
Well, if you think about what a blackboard is, what do you do with a blackboard? It's like you write shit on it. And then it like stays on there in chalk or whatever.
Okay.
And I suppose you can rub stuff out and edit it and like whatever. It's basically a storage unit for information. So a blackboard, when it comes to AI, it's a thing that is always paired to a behavior tree, which allows the behavior tree to write information onto a blackboard, like you will with a piece of chalk, and then use that information and remember that information to change the way that it makes decisions.
Okay.
So
it's like short-term memory?
In order to tell this AI where to move to, we need to record the move to location from this task onto a blackboard and then draw that information from the blackboard in this move to node. That's how this works. So, but before we can even do that, we need to pair the behavior tree to the blackboard.
Wait, so we got to do it like that.
So let me see if I can figure that out. If we go to our BT random roaming, you can see there's if you just click on the event graph, left click on the event graph, you get behavior tree, blackboard asset, and then you click that, and now it's got a blackboard, okay?
I was looking at it the whole time.
You can see it just appeared up there, because this root is reading.
Oh, and it's here. Wait, that's actually really sick.
So now, if we go over to the blackboard, you can toggle between the two just like this. So you can see, here's the behavior tree.
That's cool.
Here's where it's storing its information, which means I can close this blackboard asset now, and I won't need to open that blackboard asset again.
That's handy.
Because you can just open it from here. So if we open up our blackboard, we need to add a thing called a key, which is a different variable type where you can store information that can then be used inside of the behavior tree. So if we click blackboard, new key, we need a vector because we're storing a location. So let's just call this move to.
We'll move to.
Okay, it's a vector and it's just called move to. And the self actor will just, that's a default one, and that'll always just be a reference to whichever actor owns the blackboard. Okay, so we have a move to vector on the blackboard. So how do we write to the blackboard? Well, let's go into our get random location, and off of here, the random location, we're going to say set blackboard value as vector. And then just put that in the execution chain.
Value as
now, which blackboard value are we setting? Well, we're going to create that. We're going to make that a variable. And it defaults to the name key. But what I like to do is I call it bbki underscore. Sorry, bbko. I'll explain in a moment.
Ko.
Move to location, or maybe I'll just call it location output. And the reason I call it location output is because the name of this task is get random location near actor.
Okay.
So if you read the name location output, automatically you're going to make the connection. Okay, well that's the location that's outputted from this thing. Okay.
Okay.
Now bbko means
what does that mean?
Blackboard key output. bbki means blackboard key input. I like to differentiate between those two because sometimes.
I like that.
Let me just hit this eyeball here, so it's editable.
Eyeball. Sometimes,
if you have a bunch of different keys, you can view all those defaults by clicking on your task up here. You might have like 5 different keys, and if your naming isn't clear, you won't be sure which ones are meant to be variables that you're putting in and which ones are meant to be variables that you're getting out and then using in another part of the graph. So I use this convention bbko for out, bbki for in, and then just a descriptive name afterwards.
Okay.
So
that's actually really handy.
Now if you look at this, event receive execute, we get a random location near our radius, which we're just going to set as a default to 500.
We're clicking on the radius variable. I'm going to set it to 500.
500's a good... No, let's go bigger.
1,000?
1,000. Let's move real far.
Okay.
1,500.
Okay.
And then we're updating our blackboard value as a vector, right? We're feeding it a vector, and our blackboard key is the location output, and then we're marking it as a success, okay? So this is done. We can close that down now. But now what we need to do is we need to set this up. So the radius is fine because we're going to be moving in a radius of 1,500. But we can make that bigger. We can make that smaller. It's completely editable depending on what type of behavior you want it to run. Now, the location output, this is where it's writing to the blackboard because I've named it BBKO. If this BBKO bit was covered and it just said location output, or even just like location or something, you wouldn't be clear on what this did, and you wouldn't be sure if it was something you were meant to set or something you were meant to get.
Okay.
But anyway, so BBKO, location output, we're going to output that to the move to location on our blackboard, and then we're going to use in our move to node down here in blackboard key our move to location. So
I see it's changing
in sequence,
it too.
What's happening from left to right, we're getting a random location near ourselves, we're moving to that location, and then we're waiting for that amount of time.
Yes.
This all marks as a success. The selector marks as a success. The route continues, and then it goes again. So it'll go back through, back to the sequence, get a new location, move to, wait. Get a new location, move to, wait. And it'll just repeat and repeat and repeat and repeat and repeat. Okay? Simple blackboard behavior tree. Shall we give it a run and see if it actually works?
So wait, it already works like that?
Hit simulate.
Just do
we have a nav mesh in here? It doesn't look like we have a nav mesh. Is that something
we
that I
don't.
forgot to do? Okay, so before your AI can move in here,
Glasses?
you need to go place actors and then
Nav
type
mesh
in nav
bounds.
mesh bounds volume. Drop that in. You're gonna center it to 000, just down here in the bottom right.
Wait, no. Wait, where is it? Oh, there we go. I'm like, huh? I forgot to unpress G. This was in game mode. Boom, there we go.
And then I'm going to make that a little bit higher so you can see it, and then spread
And then
that
P.
across the whole thing. And then you
There we
just
go.
press the P key to toggle the nav
like
on
that,
and off
though.
so you can see it. But now, what's going on here?
I think
So,
it's always
okay,
like that.
you can see that he doesn't have navigation around his body because the cube is blocking the navigation. So if you go to the static mesh and then scroll down to collision presets, set that to character mesh, because it's a character mesh even though it's a cube.
Okay.
And
Character
now
mesh.
that'll stop blocking the navigation, so you can see
Ooh.
he's got green under him again. So now I'll press P again to hide that and hit play. We've got our boy moving around. Now, or girl,
Yes.
or whatever the hell he is. It is this horrible thing
Oh,
that we've created.
wait.
We've
What? It
given
actually like
cube
moves
sentience.
around pretty good too,
It's
like
just
around
gonna
corners.
roam around in this
Wait a second.
cube
Hold
world
up.
for the rest of its existence. You don't know what these things get up to in here when you turn the computer off. You don't want to know, trust me.
This
it's
is
no
so
good.
cool.
But to be honest, maybe he's happy here. I mean, he's surrounded by cubes. Like, there's cubes on the stairs, there's cubes, there's walls.
That's
Everything's
actually
made
so
out of,
awesome.
out of edges, you know?
And that's
this guy
actually
has
very,
how
very
many
simple.
edges?
There's
8
a few-
edges. 16 edges.
Oh.
I don't know, but
There's a few like components attached to that, like this, but well, this is just like the actual items or like the characters. So this is not really included, I guess, in here. This would be like separate. So this would, I should have. I was just following him, put it all in one like thing. Because this is blueprint, so this would be like AI, whatever, and then have this separated into like the actual characters. Or like if it's like animals, then you could put them in separate, because it really depends on what character it is. If it's just very simple stuff like this and my characters, but if it's like giraffe or something, then you put it into the giraffe stuff, and then have it, and then have this stuff just there. Then if you want to make, actually, I would have to watch the next stuff on how to add onto this. Like I can kind of get the idea. That's where I'll just basically have to rewatch the video and just like kind of add on to this. But there's another video to watch as well.
it's got some edges. And you can see over here on the right now. So
The IQ to take over the world.
This is the cool thing about behavior trees is you can literally visualize, oh, I can't move that while it's running, but I was going to drag that across so you could see it a little better. But on the left, you can see him moving around, and on the right, you can see what he's thinking. That's literally what he's thinking. The behavior tree is like the thought process of an AI.
Oh, I see.
So you can see he's running the sequence node. He's waiting. He just got his location instantly. He moved to it. Now he's waiting.
Oh,
now he's moving,
I was
now
like,
he's
is that glitching out? But no, he's doing it instantly.
All right. So simple. So that's how you think of it. This thing on the right is his brain. This is his thought process,
cool.
how he makes his decisions, and then you can see what that looks like on the left of the screen.
That reminds me of Little Big
here.
Planet too.
So I think I might
Maybe it had a
leave
system
that
like that
there.
too.
This is a basic introduction to behavior trees.
Yeah.
I do have more advanced behavior
blue
tree
one?
content on my channel. I have an AI made easy series, which I go into quite advanced stuff, to be honest. This is a very beginner tutorial to just get you started with behavior trees and see that they're not something to be afraid of. They're really, really simple, and they're incredibly powerful. Like once you get the hang of what you're doing, and you start to build up a lot of these
this is awesome.
tasks, if you've designed these properly, you can migrate these from project to project to project and basically build up your own library of different AI behaviors, which you can
what I'm going to be
reuse
doing.
to every AI that you ever create from that point onwards. It's like once you design a task, you know,
the
you just
collision.
copy it to a new project. And you
The
can reuse
capsule
it.
models preventing us
You
from
end
getting
up
on top of
being
them,
able to
which
do
is
really
good.
good complex behavior.
So you can't
trees.
just
Let me
ride
just
them.
show you one more thing, just for
Maybe
the
you want
sake
that.
of like demonstrating the power of this. This is our random roaming behavior tree.
Yes.
Let's create a new behavior tree.
That's what. Okay, so you do make a new behavior
BT
tree.
underscore move to random point near self.
Hold up. BT point near self. Right? Let's see.
That's basically the behavior that he's doing, right? This whole thing.
So
he's
then what are we
basically
doing here?
moving
Then
to a
we-
random
okay, why are we
point
doing
near
this
self,
then?
and then he's waiting. So if I wanted, I could cut that, open up that new behavior tree that I just created, copy that in, boom, just like that, because that's what it's doing. Now, in here, I can say run behavior, and then
Okay, hold up. I should do this. I'm like, okay, hold up. Boom. 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 That's actually really easy to copy and paste, especially with the node within node thing. Then run behavior. Okay. Behavior asset.
in behavior asset, move to random point near self, just like that, and then if
Oh, okay. So it is. Okay, so you can. Okay, so you. That's how you would do it. At least I probably would do it for a while, and then I'd probably get a little bit more complicated with like one whole thing kind of having all being within itself.
if that fails, then we wait. So this is
That's
how
so
you
cool.
collapse.
Then you can add
your
more stuff
behavior
here
tree
too.
Graphs. So basically, you could have a big ass behavior tree of itself inside of here, which could be a very specific type of like combat, for example, or an evasive behavior, or a searching behavior, and then you could have like 10 different ones of these, and then have like a meta decision making process between which behavior tree to use.
Awesome.
Just
really so
so
simple.
you know, like you can collapse these and just make the most complicated shit inside just a single node like that, and then have a monstrosity of behavior tree selecting between different behaviors of their own. So the sky's really the limit, right, with the kind of shit that you can do with this. So just to demonstrate that running,
That's awesome.
you can see he's just running that one behavior, and it'll always succeed because, I mean, there's no point where he's ever going to fail it. When he might fail it is if you introduced a condition where he would only roam if the player was X distanced away or whatever. But you can look into my AI Made Easy series if you want to learn a little bit more about that sort of stuff. But
Yeah, man.
let me know if this is helpful, like slowing this down like this. And and if you would like more tutorials like this, because if you do, I will, but you need to let me know, because otherwise I don't know if anybody's watching them. I feel like a lot of the so-called views on YouTube are literally just like bots and like not even.
I feel him, but yeah, sub to him 100%. That's actually really amazing that you could actually collapse it in this way. But yeah, amazing tutorial, especially in the way that he's broken it down into the way that he did, which I like to say that's like the Blender Guru style. When you watch the donut tutorial, he did it in that way. He really broke it down, very simple, and that's what made the tutorials into so many different parts, because he really broke it down. And it could have been like 1 hour tutorial, but if he did put all in one tutorial, it'd probably be near like 3 to 4. So having that being said, this of what we just made is, again, really simple, very quick and easy, especially once you know what you're doing. Especially if this is something that like you're really interested into and you like really dive in, then this is stuff you're going to be able to call on home instantly, or call from different projects, because again, you can copy and paste that stuff, but then add on top of it and get even more complicated with the actual behavior trees themselves. And run behavior, having it where the behavior tree, I can do this. This makes it super simple for me. Of like, okay, so behavior, okay, this selector, okay, go through, run behavior, I wonder if you could rename this. Actually, yeah, node name, so definitely this would be get random point. Yeah, so get random point, select, wait, boom, boom, nice. Because that's when he said you can have more advanced stuff, so it'd be like, look for player, if found player, if not find player, and that would be like move, right? So like find player or loop, find player and find player would include the movement, so it'd be like 3 nodes, or maybe 4 because of wait. So it'd be like find player, attack player, because if it doesn't find it, it will skip. And then what to do if you don't find player. So then it'll loop. But if it, or maybe just even be 2, because then it would just cancel and go right up. So it'd be like find player, then just be attack. Boom, find player, then just attack, then maybe wait. Because it's that simple. It's like you want to overcomplicate it, but that's not how it's actually done. So that's actually really dope. And I love, because this stuff actually, these little cubes reminds me of a they're so good. They work so well already. They remind me of a workshop add-on in like Gary's mod. There's a wired mod add-on that had like a coding tool that you could legit code stuff. Like actually put code within the game and then create stuff like this, which is pretty sick. It's called E2 expression, and people pasted some of their designs on the internet, and there's one of like a blob that would just like jump, wait a few seconds, jump, wait a few seconds, and then it would grow as time continues. Just as like on a time scale, and now to kind of actually create something like that in cube form that moves like this, it's legit that thing. And to make this a little bit more complicated, we can make it where we can figure out how to make it jump into more of that, which might be an animation, but that straight up could probably be some vector stuff as well, some simple vectors like that, how it just like kind of just like simple like jump and then move, something like that. And now it'd be simple enough to be probably as simple as that like little blob in that thing. And it could be like a little creature, which is awesome.